Please join me in welcoming to the Distinctive Voices podium, Dr. Peter Hotez.
Jennifer, thank you for that very kind introduction. Can everybody hear me okay? Great. I'm going to actually not stand behind the podium because I've noticed over the years some of my stature, when you stand behind the podium, all you see is podium. So I'm going to try to kind of be out here. And I thought we'd make it a little more interactive, sort of a lecture, but also kind of a discussion as well, which would make it certainly more fun for me and I think more engaging for you. And please feel free to interrupt and ask questions as I'm going. I love the feedback. I love the interaction. And I'll throw out some questions to you as I go along. So tonight, what I'm going to be speaking about is it's a part science lecture, but part of not a science lecture, because I've devoted my whole life to trying to provide access for new drugs and developing new vaccines for diseases of the world's poorest people. And the biggest problem that we're facing right now is there are scientific hurdles, but it's really the business and legal challenges that we're facing as well. So that's why I say it's both a science lecture and not a science lecture, because we're going to talk a lot about some of the big forces that are preventing us that are non-scientific in terms of actually developing these new interventions. And so I'm going to start here. And they're called the Millennium Development Goals. How many people have heard of the Millennium Development Goals, or MDGs? Not too many. So this is an interesting document that was put forward in the year 2000 at the start of the 21st century. That was why it was called the New Millennium. What happened was Kofi Annan, who was Secretary General of the United Nations in 2000, he just passed away a few weeks ago from Ghana. What he did was he brought all global leaders to United Nations headquarters to this unprecedented meeting where the heads of state from all the countries of the world came to UN headquarters on the Upper East Side of New York to address the plight of a group that was then called the bottom billion. What do I mean by the bottom billion? Anybody want to venture forth what I mean by that? Poorest of the poor, right? The billion people in the world at that time who live on no money, or as the World Bank then said, live on less than $1 a day. And to draft these goals to lift those individuals out of poverty. So the Millennium Development Goals was actually an anti-poverty document. And what was interesting about it, and these are the goals represented here by these little cartoons, was that 3 of them were devoted to health, which was not intuitive at the time. The idea that being sick not only was a consequence of poverty, but actually could cause poverty because of healthcare costs or making people too sick to go to work or impairing childhood development. So there were 3 goals that were devoted to health: to reduce child mortality, to improve maternal health, and this one around infectious diseases, to combat AIDS, malaria, and other diseases. So let's go to that number 6 one, because that one in some ways was the most far-reaching in terms of actually providing dollar support for an intervention. So it's Millennium Development Goal number 6, to combat AIDS, malaria, and other diseases. And this is what led to George W. Bush launching in 2003 something called PEPFAR. Anybody know what that is? It's an acronym. It stands for the President's Emergency Plan for AIDS Relief. And what it did was, for the first time, put people all across Africa and parts of Asia on antiretroviral drugs to prevent HIV/AIDS transmission. And it's one of the most ambitious global health programs ever undertaken. Anybody know what it costs, since you're paying for it? It's about $8 billion a year. So it's real money, right? So what's the budget of the NIH, the National Institutes of Health, just for kicks, the annual budget? It's around $36 billion. So you're talking real numbers really getting up there. It also launched something called the Global Fund to fight AIDS, tuberculosis, and malaria. So they added tuberculosis, so it was to combat AIDS, malaria, and other diseases. And this was really starting to make a difference in the lives of the world's poorest people. Now, there's one problem with that Millennium Development Goal number 6, and it's kind of a what am I thinking question. Let's look at the goal: to combat AIDS, HIV, AIDS, malaria, and other diseases. What's the problem with that goal? Anybody want to make a guess? What? Yes. Okay. What's the one? Just don't overthink it. Just what's weird about that goal to prevent AIDS, malaria, and other diseases? Does this bother anybody? Other diseases, right? Believe it or not, so calling something called other diseases didn't get people too excited. Uh, and, and so this never happened, right? You didn't have a conference, a summit with Bono and Tony Blair and Bill Gates saying other diseases, right? So, and that was a problem for those of us like myself and colleagues who worked on other diseases, because we found ourselves on the outside looking in on all these exciting developments that were happening in global health. People were being put on antiretroviral drugs, people getting treated for malaria, but for other diseases, including a lot of the parasitic diseases that we were interested in, were diseases such as hookworm or schistosomiasis or leishmaniasis. I like to call them the most important diseases you've never heard of. We were on the outside looking in. So what we did was kind of interesting. We were scientists. I say we, I mean myself, David Molyneux, who is the head of the Liverpool School of Tropical Medicine in the UK, and Alan Fennick in Imperial College London, and people like Lorenzo Savioli, who was then at the World Health Organization, got together and actually went and did a branding exercise. Rather than calling the other diseases, we call them the neglected tropical diseases, or the NTDs as an acronym. And our original list had about 13 or 14 diseases that had the following features. They were highly prevalent among the poor. They were endemic in poor countries. They tend to be chronic and disabling conditions rather than killer diseases. And that's very important because a lot of them were disfiguring. They caused a lot of stigma. And this was the most important part of all. They not only occurred in the setting of poverty, but they were a stealth cause of poverty because of their ability to trap people in poverty through making people too sick to go to work, through shaving IQ points off of kids, through affecting pregnancy outcome. And then I went and wrote a book about these diseases, which my kids started calling Dad's Forgotten Book on Forgotten People with forgotten diseases, as only loving children could do. But now it's in its second edition, even got a Japanese translation. So I'm going to show you a little bit about these diseases and why we need to care about them. So this is one of the most common ones. It's called, you know it as elephantiasis, if you know about it at all. The real name is lymphatic filariasis, and it's a parasitic worm infection that causes horrific disfigurement of the lower extremities and makes people too sick to go to work. So this individual here says it's quite a problem for me when I have to stand at work for long periods. India was losing $1 billion a year through this disease. Now, so everybody in this room understands why this disease is important now. But one of the problems was it's not a killer disease. And why is that a problem? Well, it's a problem when you're trying to raise awareness and advocacy and getting people to care about these other diseases. Because imagine I'm on a panel now on Millennium Development Goal number 6, and this used to happen all the time. You know, you'd have the AIDS person there talking about AIDS orphans, people dying, or the malaria person will say, in the time we've been talking, 200 children just died of malaria. And then I'm there, where's my soundbite, right? This is not a 30-second UNICEF commercial. This takes time to explain. And so it's very hard to get people to care. Here's another one, female genital schistosomiasis. How many people have heard of it? Nobody, right? So believe it or not, this is probably the most common gynecologic condition of girls and women in Africa. Some estimates, our estimates are 100 million girls and women have this disease. And it's caused by a parasitic worm that's in the bloodstream. It deposits the eggs that have a spine on it to get into the cervix, uterus, lower genital tract. It causes pain, bleeding, and stigma. It's grounds for marital discord and depression, but it's also now been associated with a 3 to 4-fold risk in HIV/AIDS transmission. This is probably Africa's most important cofactor in its AIDS epidemic that you've never heard of. So this gives you another reason why it's so important. So here's the list, our current list of these diseases. The World Health Organization took our original list of 13 or 14, expanded it to 20, which is fine. And here's the list. And don't go too much in the specifics. I just want you to look at the size of the numbers. 800 million people with ascariasis. What is that? What is that, by the way? It's a parasitic worm infection of the intestine. So the most common affliction of people living in poverty is a parasitic worm infection. In fact, a lot of these are wormy diseases like hookworm and whipworm. Here's malaria for comparison, schistosomiasis, scabies. The point is every single person living in poverty has at least one of these diseases. So what are we going to do about them? Well, what we did back in the early 2000s was we noted that the big pharmaceutical companies like Merck and Pfizer and GlaxoSmithKline had developed medicines for diseases of places like the United States, but they could also be repurposed for treating on a mass scale by targeting whole populations neglected tropical diseases. So a good example is the antibiotic Zithromax. Anybody ever take a Z-Pack? Anybody not take a Z-Pack, right? I mean, right? What'd you take it for? Your sinusitis, your strep throat, your ear infection. Pfizer makes $1 gazillion on it, but it also works for a neglected tropical disease known as trachoma. And what we did was we worked with the pharmaceutical companies to take all those medicines and put them into a package that could be delivered once a year. And because the medicines were being donated by the big pharmaceutical companies, it kind of factored out the cost of the drugs. It was just the delivery. And these drugs are so simple to give and have such a good safety profile that they don't have to be given by a nurse or a health professional. They can be given by school teachers or community health workers. And so we actually costed out this package, which we had to give it a cool name. We gave it so people would care about it. We called it the Rapid Impact Package. And this is the cost now for, in dollars, of a year for antiretroviral drugs for HIV/AIDS. Here's the cost for anti-malarial drugs and bed nets, which is still a very good deal. But here's our package, which was practically free, which targeted the 6 or 7 most common neglected tropical diseases of humankind. And a lot of times people had multiple NTDs at the same time. So the same person who has schistosomiasis could also have onchocerciasis or have hookworm, so that you'd be treating multiple diseases at the same time. And yes, sir. So that's a great question. So we're only struggling with that now. And so it's something that I never thought of when we first were designing the package. Now people are coming back to saying, well, Peter, you did a great job getting this package out there. We've now treated 1 billion people with this package. But, have you disincentivized pharmaceutical companies for further innovations for neglected diseases if they know they're going to have to give it away at the end of the day? So that's an important philosophical question, which we're still struggling with. But here's what we did. We wrote about this idea of packaging the medicines, this concept of what the neglected tropical disease is, and packaging the interventions in 2 back-to-back papers in the Public Library of Science in PLOS back in 2005. And then what? So we wrote these 2 papers, and what do you do with the information? Why do academics write papers? Because they're academics and they write papers. But why else do we write papers? What share information, and what's our hope that we'll get out of it, especially if you're a scientist at the University of California, Irvine? Tenure, but to get tenure, you need grants, right? People are going like this, right? So we write papers in order to get grants. And why do we get grants? To write more papers, right? That's what academics do, right? We write and we go. But the problem was this: we actually wanted to get funds appropriated through the U.S. Congress and my colleagues at the UK through the British Parliament to actually get this package deployed. And the problem was we were dealing with something we called other diseases, not neglected tropical diseases, and there was not really the interest to really move this forward. So this is an interesting lesson in getting out of your comfort zone and stepping away from the grants and papers to actually talk to members of Congress and to the executive office building of the White House, which is what we did. We worked with the Clinton Global Initiative and and the Bush administration. And I would at that time I was chair of microbiology at George Washington University, which is just a few blocks from the White House. And I would take a taxi at my own expense and go to the congressional office buildings and talk to anybody I could and try not to get arrested and talk about neglected tropical diseases. And it actually worked. And in retrospect, it worked for reasons I didn't understand at the time, which was one, the Bush administration had just launched PEPFAR, and they were so excited with the results that they were looking for another big global health program. And the other difference back then was, at that time, Democrats actually spoke to Republicans, and Republicans actually spoke to Democrats, right? So things weren't as polarized as they were polarized, but not as polarized as they are today. And the International Business Times wrote this article, how 3 scientists marketed, and it was very much marketing, neglected tropical diseases, raised more than $1 billion through USAID and through the British Parliament. So it goes to show you, and this is what I tell my graduate students and postdocs and young faculty, if you're willing to take the time to do public engagement, you can make an enormous difference in this world. And this is why I think these kinds of venues are so important, because scientists don't engage public audiences enough. We're so used to writing and speaking for each other that we've lost our ability to communicate science. Yes, I'm sorry, I didn't see you in the back because of the lights. So I did not give her a $20 bill to ask that question. And I want you to hold that question, because we're going to come back to it. We're very much going to come back to it. But on the short, this is what's happened now over the last 10 years or so. So the Gates Foundation, one of the things they've done is they've created an interesting organization called the Institute for Health Metrics and Evaluation. It actually evaluates whether these big programs like PEPFAR and now this USAID NTD program actually works. And the numbers have just come out, and what we've seen is about a 30 to 40% reduction in the prevalence of a lot of these diseases. So we think we're making a lot of progress. And one of the diseases, lymphatic filariasis, now it actually can interrupt transmission of the disease. So we think we can actually eliminate that disease through mass drug administration. But the others, we're going to come back to that, they come back. So you have to continually apply the pressure of the medicine, which also makes you worry about what? Yeah, drug resistance too. Is drug resistance happening? We don't know. No one's funded to look for it. So this gets into a lot of problems as well. Now, so while that's going on, those of us in the NTD community, we are meeting annually at the American Society of Tropical Medicine and Hygiene meetings, and everyone's high-fiving themselves for the success. But then, as John Lennon once says, life is what happens in between plans. Stuff started to happen, which is causing the reemergence of other neglected tropical diseases. And the forces that are doing it are not something I would have predicted back in 2000, because they're intuitively not very obvious. And I'd like to briefly go through those. So one of them is war and conflict. That's kind of interesting. Why would war and conflict cause a rise in neglected tropical diseases? The shifting poverty that we call blue marble health, and a piece of climate change as well. So let's go through some of these forces. So why war and conflict? Right, so basically it collapses the whole health system infrastructure. So you can't do vector control, you can't do mass drug administration, you can't give vaccines. That's absolutely right. So for instance, why did Ebola rise out of Guinea, Liberia, and Sierra Leone in 2014? It wasn't necessarily because it was tropical, although maybe it was a component of it. The whole health system had collapsed through years of atrocity. So knowing that, what's the next hotspot? We're in Ebola, but probably won't be Ebola, but where you're going to see a rise in neglected tropical diseases. Syria, Yemen. Yeah, you're absolutely right. So Syria, Iraq, Libya, and Yemen, this is what we're seeing now. We're seeing, yes, ma'am. Perfect. So let's look at what's happening now in Syria and Iraq and Yemen. So we're seeing now the return of measles and polio. We've seen that. Um, we've two major neglected tropical diseases, leishmaniasis and brucellosis, are taking off. I'm sorry, leishmaniasis and schistosomiasis. We're seeing collapse of international borders, so animals are being trafficked, so zoonotic diseases, diseases transmitted from animals to humans, are taking off. And things are not static, right? People are actually now, as the migrants are being displaced, moving into Lebanon, moving into Jordan, moving into Egypt, moving into Turkey. We're seeing now the emergence of those diseases there, so it's destabilizing the whole region. Here's one of the diseases we're working on. It's called leishmaniasis. It's not a killer disease, but it's highly disfiguring. It's transmitted by sandflies, and what it does is it injects the parasite into the face, the skin of the face, and causes terrible disfigurement, especially for girls and women who are rendered unmarriageable. It's grounds for spousal abandonment. It's a disaster. Hundreds of thousands of cases now of leishmaniasis in Syria and Iraq. How many have heard of it before? So not too many, right? So this kind of goes on silently. It's a parasitic infection. It's a protozoa, and there is a treatment, but it requires injection in the lesion of a drug called stibogluconate. It contains antimony. And of course, the drug's in short supply. There are no healthcare providers to do the injections. So this goes on and on. What's going on in the Western Hemisphere? Right? We have our own little problem here, right, with Venezuela, right, with the collapse of the health system there. Same thing is happening. It's not so much war, but Chagas disease, leishmaniasis, urban schistosomiasis, malaria, dengue, chikungunya, and Zika. And what about the diaspora from Venezuela? Where are they going? Colombia, Brazil, Ecuador. So Venezuela one time was leading the elimination of these diseases in the Americas. Now it's destabilizing the whole region. So war and conflict is a bad one. Another really interesting force is this one, which is the subject of my second forgotten book that I wrote in 2016. And it's called Blue Marble Health. And this is an interesting analysis that we did from data from the World Health Organization, but we also used data from the Gates-funded Global Burden of Disease study. And we're still trying to get our arms around it, and it's not intuitively obvious, but it goes something like this. When you add up where most of the world's neglected tropical diseases are, I would have thought that overwhelmingly these would be the poorest, most devastated countries of sub-Saharan Africa. You know, the Congos, the Central African republics, and they're certainly there. But on a numbers basis, the largest number of people living with neglected tropical diseases, these chronic and disabling infections, are actually in the G20 countries. What are the G20 countries? The rich ones, right, yeah, the 20 wealthiest economies, plus Nigeria, which is not a G20 country, but actually has a total GDP higher than the bottom 3 or 4 G20 countries. So the G20 countries have the largest number of people living with worm infections, leishmaniasis, tuberculosis, dengue, Chagas disease, leprosy, the list goes on. But it's not uniformly concentrated in those countries. It's in where the poor are concentrated. So an example is Argentina. If you go to northern Argentina, incredible poverty and disease in the Chaco area, or northeastern Brazil, which is where Zika arose, right, in 2014, but that's also where you have the leishmaniasis, the Chagas disease, the schistosomiasis, or southern Mexico. What's the most provocative thing I did on this map? The U.S., yeah. So does the U.S. have poor people? So how many? Anybody? So the UN Special Rapporteur for Poverty visited the United States all of last year, and his team. 19 million Americans living at half the U.S. poverty level, and about 5 million Americans living on less than $2 a day, the same benchmark for poverty we use anywhere. And it's mostly concentrated in the southern part of the United States. So one of the things that we've done in our School of Tropical Medicine, which is located in the middle of it all in Texas, is we've taken that global health lens and flipped it inward. And what we're finding is pretty extraordinary. So we've just, Vice News just reported on this last night. But we've now done an extensive study in Alabama led by Rogelio Mejia at our School of Tropical Medicine to find a significant level of hookworm infection in rural Alabama. Yes, sir? No, because the World Health Organization set a target of 1 per 10,000 as, quote, eliminated. But the problem is we've gotten there and leprosy still keeps coming back. So it's not quite eliminated yet. And we have leprosy in Texas, for instance. And so what's going on here in Texas? So this is where child poverty is found. It's, of course, along the border with Mexico, but not only there. So this is a picture along the border with Mexico, and it's like something out of a tropical disease textbook, right? We've got the standing water, discarded tires that breed Aedes aegypti mosquitoes, substandard housing without window screens. But it's not only there. This is just a few miles from the medical center where I work in Houston. Same kinds of things happening. So we're finding widespread neglected tropical diseases in the state of Texas. So Christy Murray on our faculty has been leading this effort, looking at finding Chagas disease transmission and typhus and Zika virus infection, of course, in South Texas, and dengue, and the list goes on. So all together in the Blue Marble Health book, I estimate around 12 million Americans living with a poverty-related neglected disease. And the interesting part for me about this is I can't get people to care about this. So it was not that hard to get people to care about NTDs in sub-Saharan Africa. But the minute I talk about NTDs among the poor in the US, the lights go out. Why is that? By the way, I'm genuinely asking, why is that? I don't know. Denial? There's something about the difficulty in getting people to admit that we have that level of poverty. There's also this flyover nation concept, that book, Flyover Nation, that says, what gets on CNN and network news is what's in Brookline, Massachusetts, and Westchester, New York, and Bethesda, Maryland, and Orange County. But when we talk about the middle of the country, maybe that's a component of it. We've recently gotten Senator Cory Booker interested in this. And so we're hoping to get some legislation, but it's been a really tough sell so far. What about climate change? What's going on there? I don't want to ruin anybody's plans for a vacation in Southern Europe, but when you talk to the climate change people, they'll tell you that next to the Arctic, Southern Europe is the next shoe to fall. And sure enough, we've seen all these weird paranormal phenomena where malaria has returned to Greece and Italy after it's been gone for 70 years. We now have schistosomiasis in the island of Corsica, dengue in Portugal, West Nile, chikungunya in Spain, Italy, and France. So is this climate change? Well, it could be, but are there other things going on? What else is going on in Southern Europe that could? So is it people coming across the Mediterranean, fleeing the conflict zone? And what else is going on? What's happening to the economies of Greece? And people are going like this. Yeah, exactly. So what is it? Is it the poverty? Is it the human migrations fleeing conflict? Is it climate change? So it turns out we have absolutely no idea. So why is it that we have no idea? Basically because nobody talks to one another. So if you're a virologist at the University of California, Irvine, what's your incentive for going across the way and talking to a political scientist or talking to an economist or talking to an earth scientist? Maybe it's better here than most places. Most academies are pretty siloed, right? We don't talk to one another. If you're a virologist, you want to get promoted, you have to write and speak for other virologists and write grants and papers for other virologists. So we have to figure out a way to get that kind of crosstalk. I mean, can you imagine if you could channel the horsepower of the University of California, Irvine for these kind of interdisciplinary problems? Right now, we don't even have a system to approach it. What would you do? I mean, let's say you were to present this across the university. All this weird stuff's happening in Southern Europe, figure it out. How would you even be able to begin attributing risk to climate change versus human migration? It would be very tough to do, but I think this is going to become more and more important for us. Okay, let's switch gears a little bit now and talk about what are we doing about it? Well, there's a lot of different approaches we can take, right? And what we're doing at where I am is we're trying to develop vaccines for these neglected tropical diseases. And the problem there was probably best articulated by David Letterman. Before he grew his beard long, he said in 2014, he made the following very important comment. He says, Pepsi, this was when things were really blowing up in Guinea, Liberia, and Sierra Leone. And we were worried that Ebola was going to move into Nigeria. We had the Ebola cases in Dallas. And he very importantly said, Pepsi has a new Doritos-flavored Mountain Dew. No, we don't have an Ebola vaccine, but we do have the Doritos-flavored Mountain Dew. So what did he mean by that? Well, what he meant by that, I think, is he undoubtedly knew that the fundamental paper describing the Ebola vaccine was published in Nature magazine in 2003, but it sat there as a technology that was largely undeveloped into turning into a manufactured vaccine for clinical testing. Because why? Didn't taste like Doritos. That was problem number one. And problem number two, there's no financial return. There's a huge public health return, but not a financial return. So what happened? Well, the vaccine kind of moved along, slowly moving into clinical trials. But then by 2014, things were getting very dire, right? And we really wished we'd had an Ebola vaccine. And what the Obama administration did then was they put up $200 million through BARDA, the Biomedical Advanced Research Development Agency, to incentivize industry to come in and take this on and actually turn it into a vial of vaccine for clinical testing. And they did. So Merck, GlaxoSmithKline, Crucell all stepped up and did this, and they began clinical testing in early 2015. But what had happened by then? Ebola had disappeared. Why? Because we had sent in the US Army, we put in a health system infrastructure, and that ultimately solved the problem. But not until 11,000 people died, right? So it would have been nice to have an Ebola vaccine. So the world looked at this, including Bill Gates, the Gates Foundation, the Wellcome Trust, the Norwegian government. They got together at Davos, the World Economic Forum, the following year in 2016, and they launched a fund, a global fund for vaccine development called CEPI, the Coalition for Epidemic Preparedness Innovation. And the idea was to raise $2 billion. They raised around $600 million to launch efforts. And with that $600 million, they thought they could launch efforts for 3 vaccines. And they picked for 3 vaccines, Nipah virus infection, Lassa fever, and I'm having a Rick Perry moment here. Lassa fever, Nipah virus, and MERS coronavirus infection. So let's talk a little bit about those targets. Are those good 3 targets? They weren't on the list that I had. So how many people have those infections right now today? Roughly. Yeah, rounds off to about 0. So the point is they very much focused on diseases of perceived pandemic potential rather than disease that we're talking about. So we still haven't solved that problem. So what we've done at Texas Children's Hospital, and this is the building that we're in, so the Texas Medical Center, I invite you all to come visit. It's the world's largest medical center. It's a medical city of 60 institutions and 100,000 employees. This is incredible. It has more building space than downtown Los Angeles, the medical center. And we set up in one of those buildings, and it's called the Feigen Center of Texas Children's Hospital, where we've set up what my kids would call Dad's Guaranteed Money Losing Company. And it's a nonprofit called the Texas Children's Hospital Center for Vaccine Development that's making vaccines for neglected tropical diseases. And I'll just tell you briefly about a couple of those vaccines. Before I do that, let me tell you the approach that we've taken. We used what's called a reverse vaccinology approach, which if you're not a scientist, I won't go into too much detail, but basically we have one vaccine today that was done through reverse vaccinology. That's the meningococcal B vaccine. That was developed by a man named Rino Rappuoli at a company called Novartis that was taken over by GlaxoSmithKline. And what he did was very elegant. He used cutting-edge biology in terms of omics and gene editing and RNA sequencing, looked at the genome sequence of Neisseria meningitidis Serogroup B did in silico prediction of vaccine candidates, identified about 600 of them, and then through high throughput protein expression, expressed 350 of them, purified the protein, made a mouse antibody. The mouse antibody was able to identify 91 exposed on the surface of the bacteria susceptible to the immune system. Then they down selected to 28, and then they had their final vaccine. It's just a really elegant approach. We're trying to do this now, not for bacteria, but for parasites like schistosomes and trypanosomes. And it's still a bit of a holy grail for us, in part because the genomes are very large. So the genome of a schistosome or a trypanosome or a leishmania parasite is basically, for all practical purposes, is the size of a human genome. And we often cannot use bacterial expression systems. We get aberrant disulfide bond formation, so we have to go through eukaryotic expression systems like mammalian cells or insect cells or yeast, and so it's low throughput, not high throughput, and there are deficiencies in the animal models. But having said that, we've made progress now in 2 vaccines that are now in clinical trials, one for schistosomiasis and one for hookworm, and the areas in purple are the major areas where these diseases are found. For our schistosomiasis vaccine, we took what's called an immunomics approach, which was led by Alex Lucas, who was with us in Washington. Now he has his own group at James Cook University, together with Jeff Bethany, who's at George Washington University still. And what they did was to look the spot on an array plate, all the surface proteins of the schistosome, and then pan it with serum from resistant patients. And we were able to identify this one surface protein called SMTSP2 that gave very high levels of protection when we vaccinated mice, and then challenged them with the larvae of the schistosome and showed it was a good protective vaccine. And now, through support of the NIH, through a vaccine trial evaluation unit funded by the NIH, led by Wendy Keitel and Robert Atmar, we've now been able to show that this is giving good levels of antibody in a phase 1 clinical trial in people. So we're able to take the vaccine in our guaranteed money losing company all the way through discovery, through process development, through manufacture, through phase 1 clinical trials, showing that it's both safe and induces an immune response. But then we're getting a little bit stuck. We're getting stuck because now we want to move into phase 3 trials, the pivotal studies leading to licensure. These are often studies that involve thousands of patients, and they're very expensive. So the problem has been for us getting investors to kind of roll the dice with us to get that all the way through licensure. And so this is another reason why we need the University of California Irvine's of the world, is because the problem we're having is not so much the innovation in the science, there's some of that, but it's mostly innovation in the finance sector, innovation in the business model, innovation in the legal framework. That's where we're getting stuck. So now these days, when the students, I pray to students all the time, coming to me saying they want to go into global health, and they're a little discouraged when I tell them to go to business school or go to law school, because that's where we really need the innovation, or go into economics or go into political science, because the problems of global health are so multidimensional. This is our hookworm vaccine, which takes advantage of the blood feeding apparatus of the hookworm. And the worm this is a cross section of the gut of the hookworm, and it breaks open red blood cells, feeds on blood, and then it degrades it through a series of enzymatic steps, and we can genetically engineer those, make an antibody to it, and this is actually a worm recovered from a vaccinated animal, and you can see the antibody is attacking the worm. So this one also has now gone through phase 1 clinical trials, and we're very excited, and we're ready to go on to move into phase 2, which we now have funding for, but then getting to phase 3, we're getting stuck. So we have to really figure this out. So the exciting thing about what we're doing is no one's done this before, developed a vaccine all the way through in the nonprofit sector. The terrifying thing is nobody's ever done this before, developed a vaccine all the way through the nonprofit sector. Yes, sir. And in fact, we can actually, we now work with a health economist now who can, who have done this for us. They've shown that this is not only is it cost effective, it's even cost savings. The problem is the return on investment really isn't financial. So and the other problem with foundations is there's so many good projects that they could fund. This is their biggest nightmare. It's their biggest nightmare because one, it's a lot of money, it's millions of dollars. Second, it's high risk because at the end of the day, it could potentially not work. And the other problem is the timelines are long. So I've been working on a hookworm vaccine since I was an MD PhD student starting in 1980. So we're going on, how much is that going on? Almost 40 years, and the schistosome vaccine for about 20 years. So it's an investor's nightmare. So the kinds of discussions that we have with the investors is really quite curious. And they'll say, well, Peter, this sounds really great, but we don't want to invest millions of dollars in a vaccine to see if it works, unless we know it's going to work. So how do you get around that? Well, there's a lot of interest now developing humans challenge models. That is, vaccinate normal human volunteers and actually infect them with hookworm or schistosomes. And so that's actually being looked at right now by the group at George Washington University. But it's not trivial to develop those challenge models. So again, this is where we're kind of getting stuck. We're also looking at now that we've found all these neglected tropical diseases in Texas, we're looking at now making our first vaccine that could potentially be used in the United States. So this is different risk maps of where Chagas disease transmission is going on. It's a parasitic infection of the heart transmitted by kissing bugs. We're finding quite a lot of it in Texas. This is our vaccine. It's a recombinant protein vaccine. And here we're working with a Japanese company called Eisai that's allowing us to use their proprietary molecule called E6020 that's giving us the right kind of immune response to give us very strong T cell responses. So for the worm vaccines, we need high levels of antibodies. For this one, we need T cells. And this, we're able to show in laboratory mice that we can ablate a lot of the fibrosis that's in the blue in the heart, we can actually prevent them from progressing to heart disease. And for this vaccine, we're being helped by a number of private foundations, the Clayburgh Foundation, which is the King Ranch in Texas, a company called the Southwest Electronic Energy Medical Research Institute, and the Slim Foundation. So Carlos Slim is helping us with this one. One of the things that's nice about our guaranteed money losing company is as a nonprofit, we can teach others how to make vaccines. So you can't walk into Merck or GlaxoSmithKline and say, show me how to make a vaccine. But you can with us. And so that's something that we're doing now. I took this, when President Obama went to Cairo in 2009, he talked about reaching out to the Muslim world and the arts and sciences and created this U.S. Science Envoy program. And then in 2014, 2015, 2016, he tapped me to build vaccine development capacity across the Middle East and North Africa, because most countries can't make vaccines, so all the diseases emerging out of the war conflict zones, there's no ability to make vaccines because the companies are not interested in doing that. So we've been now doing this with a vaccine for leishmaniasis, one, remember, that caused the disfiguring ulcer of the face. And here we're collaborating with the NIH. It involves both a parasite antigen as well as an antigen from the sandfly itself, because the sandfly immunomodulates the host and makes them more susceptible to disease. So this is a pretty one we're very excited about that we're hoping to develop jointly with the Saudis or the Malaysians, because we're now working with them on this. So while that's going on, we have now a new challenge, and this is one I totally would not have anticipated. And it takes a minute to explain, but let me just show you this picture to illustrate another organization that was set up at the new millennium called Gavi. It stands for, originally it was an acronym that stood for the Global Alliance for Vaccines and Immunization, and now we just call it Gavi, by the acronym. And the idea was, this was started with $750 million from the Gates Foundation to expand the use of all of our vaccines that we give to kids. So measles, mumps, rubella, diphtheria, pertussis, tetanus, Haemophilus influenza type B, hepatitis, et cetera. and to introduce 2 new vaccines for pneumococcal disease and rotavirus. And this was launched at the new millennium. This is a black and white image taken by a Brazilian photographer named Salgado, and he is an amazing photographer and once spent a year going all around the world taking pictures of kids getting their oral polio vaccine. And I like it because you see the expression on the parent's face ranging from hope to fear to joy to anxiety. I picked this one because the kid's dog is empathizing with the kid as he's getting his oral polio vaccine. We've now seen the results of that after 17 years, and the results are incredibly impressive. So in 2000, measles killed 514,000 kids every year. Now we're down to below 60,000 and almost a 90% reduction. Pretty amazing. Wow, absolutely. And that's important. That wow is important because the Gates Foundation is not going to be on the hook for all of this. We have to go to U.S. Congress and others, and so Congress wants results, and these are real results. 50% reduction in pertussis deaths, that's whooping cough, tetanus, flu. This has been a slam dunk success. I think this is probably I take pride in the NTD program, but I have to concede this is probably the single most important public health program just about ever launched. Well, we have a problem, and the problem is around the same time that the Gavi was launched, we saw the creation of an anti-vaccine movement that began in 1998. And so we're in our 20th year of this, and this is what we're seeing now. We're seeing the return of these diseases to Europe and the United States. And so this is what's happening in Europe over the last year. Thousands of cases of measles, 40 deaths so far. Italy's a disaster, Greece is a disaster, Serbia is a disaster, Ukraine's a disaster. And it's not due to importation of measles from across the Mediterranean. These are people who've never left the country. So I'm also an autism parent. So that's Rachel. My youngest daughter is an adult, has autism and severe intellectual disabilities. So I decided to start writing and speaking out about this and explaining to audiences why the evidence showing there's no link between vaccines and autism, and also looking at this movement to see if we can understand it a little bit better. So we worked with the different health departments in as many of the 18 states that allow non-medical exemptions for reasons of personal belief. And this is what we came up with. It seems to be more in the western states kind of going on. So Arizona, Utah, Idaho, Oregon, Washington State. Why? What? Anti-federal, so anti-government kind of, yes. Maybe homeschooling. By the way, I'm genuinely asking. I don't know. This is all hypothesis generating, trying to understand. Yes. So good point. So these are the rural areas. Then we also looked at the urban areas that have large numbers of unvaccinated kids, and this is what we came up with. So it's Seattle, it's Spokane, it's Portland, Salt Lake City, Phoenix, then the Texas cities mostly. So it seems very much more Western than Eastern. We're trying to get our arms around what's going on there. And then I've been explaining, really doing a deep dive into what autism is. And I point to papers like this, that's me with Rachel, by Eric Korchesny's group at the University of California, San Diego, is elegant studies showing that the changes in the brains of autism are beginning in early pregnancy, well before kids ever see vaccines. So the point being that not only is there abundant evidence showing there's no link between vaccines and autism, there's a lack of plausibility. Let me take you through this, even though it takes a minute, because I think it's very instructive, and this is from the new book. So one of the things that happens with kids on the autism spectrum is they often get diagnosed around 18 to 24 months of age, according to the CDC, and that was when Rachel was diagnosed. And now a group at the University of North Carolina, Chapel Hill, has shown that those changes in the clinical expression of autism, when it's most apparent, corresponds with a big increase in brain volume expansion. And you could follow that on serial magnetic resonance imaging, MRIs. And And that's important because parents will often remember their kid got vaccinated at 15 months of age or 18 months of age and want to link the two to say, that's when my kid became autistic after that vaccine. But now they can go back to 6 months of age and show that the changes in the brain are actually apparent by 6 months of age, to the point now with 90% accuracy, they can predict whether a kid's going to go on the autism spectrum. And now evidence from Eric Korchesny's group showing you can go back prenatally to the prefrontal and temporal cortices. And we've now identified at least 65 genes that have been linked with autism that we don't know what the upper ceiling is. We've done whole exome sequencing on Rachel, and we think we've identified a new autism gene, which is very exciting. It doesn't mean discount an environmental component, but it's probably operating through what's called an epigenetic mechanism. Ever try explaining epigenetics to a lay audience? Right? Non-coding RNAs, microRNAs, histone modification, DNA methylation, right? The lights go out. So we still have a lot of work to do. I think it's, the number right now is about 1 in 66, and that number has increased because our diagnostic criteria have broadened. Also now in many school districts, if you want to have your child, we used to call it things like mental retardation and all sorts of things. And now if you, in schools, if your child wants to get special services, sometimes they have to be put into the autism spectrum in order to get those services. And I think the numbers are about to go up again because we're getting better at diagnosing girls and women with autism. We used to say it was 10 to 1 boys to girls. It's probably much closer to 1 to 1 than we previously realized. Like Rachel, it's just that girls can camouflage their autism better. They're more socially interactive, more verbal, but they have very high rates of comorbidities like obsessive compulsive disorder, OCD, attention deficit hyperactivity disorder. A lot of the girls, especially adolescent girls with eating disorders, are believed now to be on the autism spectrum. So the whole world is changing, so that number is going to go up a lot again. Better and different diagnostic inclusion and exclusion categories, I think, also. So, of course, no good deed goes unpunished. So this is, if you Google my name, this is what you come up with, it's nonstop attacks. These are some of the nicer pictures. Why do they call me the boy who cried wolf? What's that about? Measles. They say I'm exaggerating measles. Measles was the single leading killer of children in the world after smallpox was eradicated. 2.6 million children died. And they're even circulating a book called Melanie's Marvelous Measles. How it's good for you to get measles. I don't mind it so much as long as they pick a good picture. And one where I don't look too fat. So that one I don't mind. And some of them are just plain weird. What's this one? Peter Hotez wants vaccine mandates. That's true, actually. Opposed travel ban to Somalia during Somali, Minnesota outbreak. Lives in a sanctuary city. Is Houston a sanctuary city? I don't think of it as a sanctuary city. I don't know. And so some of them are just that. So I've turned this around a little bit to my graduate students and postdocs and junior faculty and said, guys, this is partly our fault. Because again, we're so focused on our grants and papers that nobody knows what we do. And my evidence for that is still sparse, but let me tell you a couple of pieces. So Research America, which is a very nice policy group based in Washington, has done this survey to find that 81% of Americans cannot name a living scientist. And when they could name a scientist, it's Jane Goodall, Richard Dawkins, Bill Nye the Science Guy, Neil deGrasse Tyson, right? Not doing what we do as scientists in the sense of, getting a paper rejected or major revision on a paper or, revising a grant or going to lab meetings. So it's a long way of saying the American public has absolutely no clue of what we do. The Pew Research Center has found a study showing that fewer than 10% of scientists ever blog about their science or use social media. How many of you are on Twitter? It's terrible, right? I'm not saying Twitter's the answer, but you get the idea that we're too inward-looking, too focused on each other. So I don't know what the solution is. When I was getting my medical degree and my PhD at Rockefeller, the message, not even the subliminal message, the overt message was you didn't talk to science journalists. you didn't talk to any journalists, you didn't talk to the public. That was seen as grandstanding, or it was seen as, self-aggrandizement. And I think that was a mistake, because I think this has had an enabling effect of allowing anti-science movements to rise. And this is why talking to general audience like this, I think this kind of series is so important. The key is to franchise it and to be doing this in every major city in the United States, I think. Good. This is the book that'll get me in the witness protection program. It's called Vaccines Did Not Cause Rachel's Autism. It just came out, just got published by Johns Hopkins Press. It's a science book. It goes through the evidence showing there's no link between vaccines and autism, epidemiologic studies involving more than 1 million children, the lack of plausibility. I try to talk about genetics and epigenetics, but I've never seen a book quite like this, and it weaves in a very personal story about being an autism dad. Why did I get Arthur Kaplan to write the foreword? Anybody know who Arthur Kaplan is? He's one of the really important biomedical ethicists in the country. Why did I do that? Is it NYU? Because what are the anti-vaccine people going to say about me? I'm being exploitative, right? I'm taking advantage of my daughter, for personal gain. So I thought I'm not sure this is going to be a hedge against it, but we'll see. So I'll stop there. I'll just end by a quote from Elie Wiesel, who once said, "Man's weakness is not in achieving victories, but in taking advantage of them." Great gains through the Global Alliance of Vaccines and Immunization, bringing down measles deaths, only to allow them to come back in the United States and Europe. Same with NTDs, great success, only allow 21st century forces to allow them to come back. So thank you very much. Do I have time for a few questions? Okay. Thank you very much. Thank you.